First of all, thank you very much, Nicolò, for the presentation. Thank you also to the audience to be here. Today, with Anna, we would like to, let's say, give you some information regarding the name and the paradigm behind the multi-agent systems, with an additional, in my opinion, very important word that is interoperability. Okay, so merging multiple things together, and this is why I'm here with Anna. My name is Nicolò Bertozzi. I'm the, let's say, project manager plus data engineer in Fondazione Links in Flex Industries. With Anna, we are task leaders inside WP4 and also WP leaders for DWP4. And our role in our leadership is to develop, to implement the multi-agent system, and as also Nicolò said it before, the Flex Industries Dynamic Energy and Process Management platform. So the Flex Industries platform, the set of services that enable the execution of forecasting, optimization, in general simulation, and AI tools. Together with me, I'm with Hannah. Anna, I don't know if you would like to say something of you.
Yes,
At least
for
your
sure.
name.
Hi, everyone. I'm Anna Geraci. I'm a researcher in Fondazione Links. I'm a software engineer, and I work with Nicolò in this project. In particular, we are active in the field of the multi-agent system, digital twin, and also semantic and interoperability layer in Fondazione Links. And I have a master degree in mechatronics engineering and nothing more. I just here to talk with you about this platform that we implement with Nicolò.
Multi-agent.
Multi-agent,
yeah. So yeah, this is our role, this is our capability. So let's start. I will dedicate the first part with a general overview about multi-agent system, and then I will leave Anna to speak about Flex Industries and our customizations. So let's just read together the topic in order to identify the very important things in our opinion. So this webinar is about digital twins, and also orchestration is very important for us. So how to coordinate multiple things together in order to bridge the gap between the plant, the real world, so the data samples, and the IT, so the, let's say, services. So we present a multi-agent system platform that is designed to coordinate industrial simulation and BI agents. Regarding this word, regarding, let's say, the word agents, we will say you something next in the presentation. So just keep in mind, because together with the multi-agent system is one of the two keywords of today. Second part of the topic, we are introducing this stateless event-driven orchestration layer. So in this case, we have something, a set of tools that is on top of other tools, in this case the data. And the idea is to implement this interoperability as design, so by design, okay? During the architectural definition, we basically thought about the idea of merging the data, so the data flow within the architecture, plus the data coming from the industrial sites, plus the coordination and the, let's say, execution of the AI models. This was the idea, and we tried to do it with several decision support tools and unified in a digital ecosystem. So, agenda. We have our webinar split in two parts. The first is the one that I will take care of, that is the high agency. I will just try to give you an idea about what is this multi-agent paradigm. So we will, let's say, understand the definition of the agents, the React loop, the architecture for the agents, the capabilities, the dimensions, and also what is a mess. Then, so this is basically the part that I will take care. Then in the second part, we have Hannah that will take care of explaining you the multi-agent system inside Flex Industries, because the original idea is that our work is just inspired by the AI agency, okay? So we just taken the AI agency principles that I will now describe you, and we tried to just customize and adapt this, let's say, paradigm, this principle in this for this project. So I think we can start with the AI agency. So with a paradigm behind the let's say the union of multi-agent systems. What is an agent? This is probably the first question that we have to ask ourselves, and before proceeding throughout this webinar. An agent is an entity, an autonomous entity, but this adjective could be, let's say, sometimes removed. Probably Anna will say something about this point in the next slides when we will think and we will talk about flex industries. But the idea in this case is to have an entity, an object, in this case a software model, we can say, that is able to perceive reasons and text. So we are reading, we are gathering, we are analyzing, we are just, let's say, sensing something from the ambient, from the environment, from the industrial plant. We are reasoning on that data in order to act, in order to find out something in output. Okay, so it's like a human at the end. We have an entity that is able to look around and to think about what is, let's say, in the environment, what is just touching or seeing, and then it is able to make some actions. Actually, the agents today are normally implemented using LLMs. I don't know if you are aware about LLMs, probably yes, probably today with ChatGPT, it is possible to have a, let's say, a first impact with this kind of generative AIs, but these are only, let's say, AI models that are able to generate something, in this case, text, images, multimedia, because they are large and they have been trained so with multiple data. Okay, so today agents are implemented using LLMs. Today, they are implemented in this way, but this doesn't mean that we have to use LLMs. Okay, we will come on this topic later. And finally, they are goal-oriented. So we can assign to these agents some tasks, okay, and they can, let's say, complete this task also within workflows. This workflow will also will be introduced by Anna in, let's say, regarding flex industries or regarding the communication between the agents. You have to keep in mind that a workflow is only a set of tasks, okay, a set of activities. So this is why, since an agent is an entity able to complete a task, if I put together multiple agents, I'm just putting together multiple tasks. And so in this case, I'm just creating workflows, okay? So agent architecture, let's try to see what is, let's say, the agent in terms of memory, in terms of logic. Agents combine the memory, the tools, and the logic to complete the task. At the end, they have an internal decision system that allow them to complete the activities, okay? And they are able to update the decision depending on what they are just receiving. We said previously that an agent is able to perceive from the ambient, from the environment. So it is an entity that is able to iterate over its own reasonings in order to update something or to give out new outcomes. And also, this flexible reasoning makes agents more adaptive because they are able to build pipelines. Okay, a workflow is just a recipe, as I said before, a set of tasks. If we are able to execute this workflow materially, physically, we are just executing pipelines of things in general. So, just let's try to use this schema to have an idea about what is an agent. We have here the user, okay? The user normally exchange data with an agent, and the agent has these three levels of actions: perception, connection, and action, okay? The idea is that we start with the perception in order to understand, as I said before, what is in the environment. Just think about this environment and just take an action. And this is a loop, as we will see in the next slides. Okay, this is a loop that enables the agent to be continuously capable of finding new outcomes and new actions depending on the perceptions, but also depending on the previous states, on what this agent has found in the past. So, as I said before, perceptions means multiple things: camera or text. Cognition is just memory plus knowledge in order to have a decision making. And finally, we can physically make some actions in the world and monitor. This is very important, because with the monitoring, we are improving the knowledge. With improving the knowledge, we are able to implement new memories, and we are able to, at the end, repeat this again, again. So this is a loop. Okay, I thought what I have to do, what I have to do now, and what I have to do next in the future. I can take some actions, I can perform something in the real environment, and I continuously observe in order to understand if what I thought originally was true or not. So this is the React loop: reason, action, observation. It is very, very similar to another kind of loop that is well known in the literature. It is the cognitive loop. It's more or less the same. Probably the cognitive loop just have inside it multiple other things. It's not only see, think, and do, but is more like see, think, but think with the help of other things, then do, but do not only on myself, with other things, and so on. So it's a little bit more difficult, but the idea is the same. It's just a sequence of multiple activities that has to be repeated. And this is the same thing that normally humans do, okay, in our let's say, daily life. Some people just compare the AI with children, because AI at the beginning, this is stupid, and with the training, so with seeing continuously things, it is able to improve itself. This is the same. Okay, the cognitive loop and the React loop are the same also for the multi-agent systems. We are able to improve ourselves by continuously iterating over this loop. Okay, so capabilities. About the capabilities, the agents are able to exploit tools, and the tools allow the agents to call some APIs, search, execute code. Okay, so also in this case, as humans, we use our arms, our hands, our I don't know, our eyes. We use some, let's say, peripherals to contact ourselves with the world. Okay, the agents are able to do it as well with tools. They are able to improve their capabilities to connect with the systems, with some APIs, with some codes. And it is possible to do it because nowadays, in the, let's say, era of internet, we have a web server that are able to expose services to clients. Okay, in the era of agents, probably in the future, some people are calling this Internet of Agents. We will have some macro blocks that will be the agents that are able to contact some web server or some APIs, but at the end they are able to communicate and to exchange data each other to, let's say, reach the goal. In this case, actually, in order to complete this task, they are able to use some tools. So Open Weather, for instance, to get some information regarding the temperature or the forecasting of the weather and so on. Mailgun is just an example of an API of a service that is able to merge multiple mail clients. And finally, we have, for instance, Wolfram or Python to execute the math computations or just general coding scripts. So these are tools, and the agents are able to choose, okay, which tools is, let's say, the most suitable to be invoked to complete the task, and also when during the execution. Of course, with the tools, we are enabling and we are, let's say, adding capabilities to the agents. And as I said before, it's like humans with the hands that are able to touch the world, to see, to understand what is in the environment. This is the same. Okay, we are able to increment, to improve our potentialities through these tools. Agents normally do in this way. So we have three, let's say, points and topics that we can just, let's say, understand in the vision and in the overview of the agents. So their communication, as we said, their tools and their configuration. These things are also the same that we try to exploit in our work within Flex Industries. Now, these slides are just inspired by Waldias, that is, let's say, a startup about multi-agent systems, and also AG2, that is a framework about multi-agent systems. We will just touch this, let's say, tools and frameworks next in the presentation. But the idea is that we can identify three, let's say, freedoms for the agents, that are the communication, how they are able to speak with other entities, the tools that they are able to use, and the configuration. Okay. So communication. In this case, we can set up the agents to communicate in multiple ways. We can have an hierarchical structure like this one, where we have, let's say, a captain or a master agent that is able to give some task to the zones, let's say, or to the connected agents. In this case, we are more on a recursive, let's say, task, because we are able, from this point of view, to split something in multiple parts and to give these parts to the single agents. The other chance is to have a sequential flow, where we have a starting agent that is able to complete the task, and then after this one, with the execution of another one, and this execution is mandatory to at the end execute this one. Okay, so this is mandatory to have this kind of flow. In a joint, we have a continuously iteration of three agents, where normally the first agent is able to exchange data with the other, with the second, but also with the third. It's like a star where each agent is able to communicate with the others. Okay. And of course, there are pros and cons. Now, it's not, let's say, that the time is not also, we don't have time to explain and to go in detail about this kind of hierarchies and structures, because we need another webinar probably. But the idea is to give you just an introduction about the agents and about their communications. The tools. In this case, we can assign some tools to all the agents, or we can just specify these tools in a config file and then allow the agents to use these tools. So we imagine to define a task. We also identified how to split this task, this pipeline, in multiple agents. And finally, we can also say each agent, to complete this task, what has to do. For instance, just as an example, I would like that my multi-agent system is able to send me a notification via email when on X or on Instagram, a specific user has, I don't know, reached a total number of likes in the post, okay, or in a tweet. So I can just define an agent that is able to connect to the X APIs or to the Instagram APIs to see the likes, and another agent that is able to exploit the email to notify me. Okay, it's the same. And these two agents are autonomous because they are able to complete this task. Finally, the configuration. It is possible to customize an agent with some specific, let's say, features. Okay, the agent is the same. Okay, in this case, we have an agent with Claude or with GPT that just is aware about two different contexts. The first one is a data scientist, the second is a production manager. Giving to the agents a context just enable to, let's say, enable the agent to be more aware about the task and also what it has to complete. So it's very important to configure it and to give it the proper settings. So, okay, an agent is an entity that is able to perform some task, but a multi-agent system is just a composition of agents. Okay, multi-agent system, nothing more. It's just the splitting of the name. Okay, so we have some agents that are able to collaborate in order to reach a goal, and they are able to do it because they have specific tasks and they know how to reach that goal by splitting this task. The same, as I said before, the example that I've done before. So I have to just monitor the likes on the post on Instagram or on X. And so I have a multi-agent system that is able to complete this task because the agents are able to split the work and to delegate, in case, the work to others. Okay, and also the memory if they have to do it. They support a human in the loop because it is possible that the human can, like in recommendation systems, enable this React loop, and also it is possible for the user to have some, let's say, online outputs from this multi-agent system. Now, just introduce you to, in our opinion, frameworks or tools that are in the multi-agent environment and ecosystem today. The first is the AG2 that I said before. This is an agent OS, so it is an orchestration framework in this case, but it implements a completely LLM, let's say, agent communication. Now, okay, we can implement multiple communication between the agents, but the process also it is flexible, and it is flexible because there is the LLM behind it, and we have also how to generate it, for instance, workflow. And the second is Agency. Agency is an open source project, and it is more about the interoperability between, let's say, agents with standardized protocols. Okay, so through these protocols, now we don't have time to enter in detail about these protocols, but the agency group has defined some protocols for connecting the agents, for connecting, let's say, multiple levels of the agents, so the logical level and the physical level. And it is very interesting because also in this case, we can discover, compose, deploy, and evaluate the set of agents in order to have a multi-agent system that is completely up and running. In this case, we have also some very interesting partners behind it, like Cisco and, for instance, LangChain. So I think I've completed my part. My idea, my goal as agent was to, in this multi-agent system that could be the webinar, my idea was to just introduce you some words that are interesting. So the agents and the multi-agent systems, and of course we would like to give you some, I think, notions or some informations that are help, in our opinion, for you to understand how we customize this AI agency paradigm inside Flex Industries. Because the difference is that in this case, we are in a European project with several partners. Each partner, also our, let's say, AI partners that are able to develop optimization or forecasting agents, well, they have a precise role and they are not LLMs. So our idea when we thought with Anna, the architecture for Flex Industries was to implement a multi-agent system. I would let you say a meta operative OS, okay, just to have an idea. That just enable the execution of deterministic agents, and this is our role. Hannah, the floor is yours. If you want to share, or if you want to, as you prefer, I can just go next in the slides, or if you want, you can also share on yourself.
I don't know. Maybe it's better that you try to go forward.
Just notify me.
Okay, perfect. So, as Nicolò says, now we start to talk about our multi-agent system. So, our idea in the customization of these paradigms in the context of Flex Industries. So, Nicolò could go on. Okay. This is the part regarding the customization of the agents. So, how the agents are developed in our use case. So, in this case, the agents are, as Nicolò says before, are not limited to LLM-based entities, but they are more or less AI or machine learning algorithm, or also we have also simulation agent that simulate entire context with a dashboard and user interface. So our agents are focused on this type of agent, so AI and machine learning and also simulation agent. Our agents are deterministics. So in this case, they have an input and output part defined. They don't perform autonomous reasoning, and they execute specific tasks. So they are able to achieve our goals, but it's a bit after triggering by our platform. So it's something like this. According to this requirement, we customize our multi-agent system with a central orchestrator that is able to manage all the flow of data and agent interactions. And how it is possible to see here, the orchestrator is a central element that is in charge of retrieves all the communication and all the triggering of the single component of the platform. Our idea is to have an orchestrator and a general multi-agent system architectures that emphasize the distributed microservices pattern. So we have small services that make very small topics and reach specific goals, and they are distributed in a distributed environment, so different machine, cloud, and something like this. All the components inside our multi-agent platform communicate with asynchronous communication, and all the components try to be stateless, because for us it's fundamental to have the possibility of replicate it, and so to be replicable. In such a way we can distribute the load inside the platform and have optimized and improved platform distribution of the communication. Then we implement also the traceable operation through tools like Jagger and OpenTelemetry that are able to collect all the latency inside the platform and also fine-grade traceable. So we are able to understand how the single action inside the platform lasts. And in this way, we were able in the past to optimize our platform to be always better. So our idea was to trace our operation to improve it according to these metrics. And then we have the monitoring and logged activities that are carried out by some tools like Prometheus, Grafana, and Loki. Okay, Nicolò, thanks. In this slide, we just talk about the idea of our platform. The main idea that was the fact that our platform is event-driven and it's composed by a centralized orchestration. For the event-driven coordination platform, we rely on Apache Kafka. That was a broker that was very used in the event message exchange of information inside between some components. It's a central message bus, and it's where all the control messages are exchanged. Our idea is to use an event-driven platform because we want an asynchronous events communication. In this way, each component that receive a request is able to decide when is able to produce a response. And with this paradigm, we avoid that each element of the platform depends between them, so they are loosely coupled, and all the communication happen in a synchronous way without blocking the execution of other components with respect to the execution of one of them that was blocked by another event. So this is what was the main idea behind the fact that we want Kafka as central blocker. In Apache Kafka, we have different topics that handle different data models. So the data models that we define in the platform are the orchestrator task data model that travel inside the orchestrator topic, and is a message dedicated to start new pipelines. The pipelines are, as Nicolò says, we define as a workflow the definition of how the task must execute. Instead, the pipelines are the execution of this workflow. So the instance of the workflow. So how this workflow happen, which agent must be triggered, which data are necessary to execute the agent, and so on. So the orchestrator task is only a message that indicate the start of a new pipeline to the multi-agent component, so the orchestrator component. Then we have the agent task that travel on the agent topic on Kafka, and is a message dedicated to trigger the agent execution. And finally, we have the data task that was the data model and the message that travel inside the data topic, and is a message dedicated to request historical data, so to communicate with multi-agent system and data and the interoperability data center. As I said before, our orchestration is centralized. The thinking about this behind this choice was about the fact that we think that our platform must have this free core feature. Indeed, we wanted central orchestration that assure deterministic behavior and simplify debugging. So in this case, that we have a list of agents that was deterministic, could be useful to have a deterministic behavior of all the workflow without the risk of some lack of information. The central orchestration, furthermore, produce a clean integration of new agents because it's something very standardized. And in the next slide, we are able to see also how these agents communicate and receive input data from our component. And then it's able to handle data, sequencing, and fallback logic. According to this central orchestration logic, we have an implementation roadmap that presents the key requirements that our components inside the multi-agent system platform must have to handle this central orchestration. So the first important key requirement is that all our components must be replicable. Indeed, we want that in this way, all the replicas are able to load to split the load, and in this way we avoid that a central orchestration could be overloaded by a lot of requests coming from different components and different pipeline in execution in the same time. So different replicas could could handle different different tasks inside a pipeline. For this reason, we need that each component of our platform does not store local data. In this way, all the replicas are able to see this data. Indeed, we do the module state cached inside our platform. In this way, the module state is accessible by all the replica of the component, and in the same time is able to restore the state in case of fallback of our replica of this component. Finally, the central orchestration rely on asynchronous communication, as we say in the previous slide, because we want to reduce the dead time of the synchronous communication, and to have an improvement on the communication inside the platform. Okay, Nicolò, please, if you want, we can go to next slide. Okay. To conclude all these things, we can say that we rely specifically on the agent communication because our idea was to be interoperable. So in this way, we must be able to communicate with different agents, with different contexts in a standardized manner. So we standardize these three type of different messages that we exchange with the agent. The first type of messages, that was the Kafka message, was only a control message that was sent to trigger the collection of the input. It traveled on Kafka and was collected by the proxy to collect all the input that must be sent to the agent. Then the agent should be able to accept these three fields that are configuration, user, and data. These three fields contain different information that could be useful for the agent, and the agent could accept all of them or accept only one of them or something like this. So we are flexible to produce to the agent different this output with different information. The configuration field contains all the configuration that are useful to the agent to be customized and working. These configurations are more or less static, but could be updated with some API that we provide to the developer of the modules and also to the user. Then we have that was more or less the third degree of freedom that Nicolò speak in the previous slide. So the configuration of the agent to be working. Then we have the user input that are the data coming from the user request, so specific requests coming from the request of the user. And finally, the data input that correspond to the data coming from the data sources. So in this case, the one that are exploited by the interoperability layer. So how I just tried to explain before, the multi-agent system send this Kafka message to through the communication backbone to the proxy. The proxy in this way are triggered to collect all the data that are necessary to trigger and execute the agent. So we have some data coming from the data interoperability and storage that are the data key, the data field, so the one coming from the data sources. And then the metadata and caching storage contain the data of the configuration of the agent and also the data coming from the user request, because the multi-agent system cache this data before the execution of this control message inside Kafka. So the agent is able to retrieve receive this data from the proxy and produce a result. And then the result could be returned to the multi-agent system that was able to use this result for other part. So according to this pipeline, we can show also how an orchestration pipeline works inside our multi-agent system platform. In this case, as I said before, we have the workflow that is the set of tasks. These tasks are agents in execution or data request, and could be executed in parallel or also in sequential manner according to the necessity of the project or of the pipeline. And when a workflow is defined, a user can use this definition to send a pipeline request, so a pipeline execution request. So this the user can trigger this execution of the pipeline, sending it to the user APIs. Then the user APIs is able to send an orchestrator task through the communication backbone, so on Kafka, and the multi-agent system is able to retrieve this request and start to trigger the different element according to the workflow definition. So when the multi-agent system receives an orchestrator task, is able to send different data task and agent task according to the final goal of the pipeline and to produce the final goal. In this way, all the agent and data task will be executed and will be sent to the different component. And when the final result is ready, so the workflow is finished, the multi-agent system is able to trigger the user API to notify the user that the orchestrator produced the pipeline produced the results, and it could be able to see it and use this result for the goal that you want. In this slide, we produce a brief description of the use case of the Flex Industries platform. We have different workflow inside the Flex Industries project, but this workflow was one of the most completed one, and is already functioning. Indeed, what we want to say is that our platforms that compose the orchestrator part of our platform as the main goal of combine the different input and output of different modules to produce a final result. In this case, the final result was to produce a process planning optimization inside the plant of the energy, of the distribution of the energy inside the plant process. That was, for example, in this case, we focalize about the fertilization process of the Swan Farm company, that was a pharmaceutical company in Rovereto. So the idea was that this process optimization planning was composed of different input, and to reach this goal is necessary the input of different agents. So in this case, we can see that the number of agents is seven agents. The first 6 agents that are the data forecasting steam, data forecasting cold water, data forecasting electricity, and data forecasting photovoltaic panel price, data forecasting electricity price, and data forecasting natural gas price could be executed in parallel because they are independent, and so for some of them are necessary some data coming from the plant. So we just provide some data processing algorithm to pre-process this data and send it to the agent. And when this agent produce the result, all these results will be collected and sent to the data optimization process planning agent. This agent produces a final result with the process planning optimization of the process of the next day. And so we are able to produce to reach this goal thanks to the combination of different output coming from different agents, and we are able to produce a relevant goals in terms of reducing the emission of the CO2 and also to reduce the cost in terms of energy of the entire process. So in this case, we can see that the single agent are able to produce an output, but the combination of this output could produce the final goal of the user. So we has our orchestrator manner, we are able to produce the final result. So now I think that I can leave the floor to Nicolò just to conclude and make a brief summarize of the platform and our implementation. And stop. So Nicolò, if you want, you can.
Thank you. Yeah, thank you, Anna, for the presentation. I will let you conclude this webinar with only some few slides at the end. The first is the platform of Flex Industries, and just finally some minor comment about this webinar. So this is the architecture. Probably you are able now to notice the set of agents that are part of the data processing capability of the platform. Probably you're now able to just see the communication backbone and the data interoperability and storage together with the metadata and the caching storage. So these two are the ones that are able to cache, so partially and temporarily store the data, plus store also the historical data. Probably you're not recognizing the data handler because we didn't cite it. This is a component that is able to help the multi-agent system to get the data from the data interoperability storage. So we just skip this component in the previous slides in order to, let's say, not add multiple things and multiple complexities in the figures, but this is only a supporting component. Then, of course, we have the front end, because we have to show externally the results of the platform. The user APIs that Hannah explained together with the user, together with, let's say, execution of pipelines that are dependent, let's say, on workflows that are dependent on tasks. So this is just the interface between the platform and the user normally. And all these things, so let's say the models that are exposed externally are connected through a gateway. And finally, we have an entire layer of security, deployment, and management. Now, Anna just cited you some tools. The idea and the goal of this layer is to just keep track about the platform operations in order to be sure that first, the platform is up and running. Second, the components are not stressed. So it is possible to split the load, as she said, about the replicas of the stateless models. Third, we have a complete continuous integration and deployment pipeline also for the agents, because the risk of the AI is to predict, is to inference something that is not compared and is not the actual situation of the environment. So it's like to predict the value of the euro today using, I don't know, the data of only the 10 years ago, okay, before 2008, for instance. We are in two different contexts, and the probabilities of prediction are completely different. So it is mandatory for the platform, for an AI enabling platform, digital twin enabling platform, whatever, to continuously update the models. Okay, so this is the third. And finally, to give access to the users. So we have to ensure that the users are authenticated, that the user can see only the data that are reserved to them. So if I'm connected with a pilot A, I cannot see the data of pilot B. And this is the same for the pipelines. I cannot run a pipeline from the pilot A and see the result from pilot B. Now, in the case of the pipelines, probably the outputs are not too much, let's say, clear for a malicious user. But if I'm able to see the pipeline results, I'm also able to see the data. And this is something that has to be kept secret completely. Okay, so this is very important in this part at the end. And finally is the connection with external tools. We have here some VPNs, gateways that are able to connect the platform with also external branches. So this was only an overview about what we are doing. We tried to simplify a little bit let's say our work in order to just let's say open a possible discussion or give you some information, some hints about the multi-agent paradigm. So to conclude, we could say that the interoperability by design means that we are able to interconnect multiple and heterogeneous data sources, okay, by combining different data models. So we are able to merge different data models, different protocols together in order to find out a common way of storing the data. But interoperability for us means also being able to interconnect multiple and heterogeneous agents, in this case, by combining different tasks and goals. So we are on two layers of interoperability. We are able to apply a low-level interoperability with the real world, with the field, with industrial plants. And so this is a practical telecommunication, let's say, interoperability, data interoperability, but the same data interoperability can be applied on a higher layer. We can, on top, let's say, integrate heterogeneous agents that are able to complete heterogeneous tasks in order to find out the common goal. So unified, interoperable data flow, starting, let's say, from the Big Bang, that in this case is the industrial data, to the AI, to the simulation. Now, we also put some references, some resources, only just for out of curiosity. And I can only thank you with Anna for the attention. And of course, we are here for the questions if you have. Thank you very much.
Thank you very much, Anna and Nicolò. Very interesting and comprehensive presentation as usual, I would say. So thank you again. And yes, we have a couple of questions from the audience. So the first one, I think we'll get back to the first few slides. So hello everyone, sorry if I may ask, what type of agents are you referring to with this definition? So I think we will need to come back maybe at the first 5 or 6 slides. So this is the first slide.
Probably yes. This is this slide, right? Yasin, probably this was the, let's say, yeah, probably yes. Well, in this case, the agent is the definition. Well, let just me split the slide in multiple paragraphs. Well, it is already split in multiple paragraphs. If you just read the first one, we are speaking about the flex industries and the AI agents, okay? So we are referring to entities that are able to take some input, think, and at the end produce some outputs. In the second paragraph, I'm just a little bit customizing the definition to LLMs. It is possible. It is a solution. Actually, it is probably the most common implementation of multi-agent systems, okay? Because you have this ChatGPT's clones that are able to communicate. But this is not only this is it cannot be the solution for all the situations. In flex industries, we don't have LLMs. We have humans. Okay, humans with their algorithms that have some input and some output. In general, the LLMs agents are also able to produce code. The problem, in my opinion, is the security. Okay, because if I allow an LLM agent to create some code and so to be flexible, completely flexible and dynamic, okay, probably I'm introducing a lot of security concerns. And so in flex industries, we don't have problems at this point because we know the agent that we are integrating in the platform. The agent has just containerized, inside some pods, inside Kubernetes, inside some isolated environments. They can execute their activities, their algorithms. They can give us the results. In case of problems, we just cut off completely the agents. So we are not giving it our data, our things, without being sure about what this agent is. Okay, so I think that this was the let's say definition that you are referring to, and this definition is about the agents in general, the agents in the AI agency paradigm, but also in flex industries. If you read only the first and the third paragraphs.
Okay, now the second question is about, doesn't using stateless modules introduce security concerns?
Okay, thank you, Yasin, for the question. And regarding this second, well, it depends. It depends on how you would like to implement the statelessness. Okay, so well, in flex industries, the concept is a little bit difficult. We submitted a paper about this thing. It will be published in September, in case we can give you after in the proceedings the references. But it depends on how you implement this statelessness. We in flex industries just store in the metadata and caching storage the states of all the modules. Okay, and cache this state using some, let's say, certificates, some security tools like private keys, public keys. So before caching the state, we are able to, let's say, just to apply some encryption to the data before being published in our cache. And this encryption allows us to be sure that, well, if you want, you can also read the state, but it is incomprehensible for you, and instead it is comprehensible for the actor that has generated that state. So first, statelessness is not a security concern if you're able to manage the security properly. Secondly, in my opinion, in general, it is more secure the statelessness instead of the statefulness, because with the statefulness, you are, let's say, continuously storing some information somewhere, and probably this is a concern. Instead, in the statelessness, I'm sure that I, as platform manager, as platform in general, I will give you all what you need to perform your activities. So I am the responsible for that data. I am the platform. I have implemented security paradigms. So I'm sure that when I give you the data, you are able to read this data. And whenever you have to give me the result, I will take care of controlling your result. But without giving you let's say, the capability of storing data, I'm sure that the data is managed by me. And if you trust me, we are okay. If you don't trust me, we have a problem. But I think that you will trust me. So you will be sure that we store the data in a secure way.
Okay. Thank you for the explanation. And just to conclude, again, thank you to Anna and Nicolò for the presentation. And yeah, for this webinar, that's it. I don't know. I don't see in the Q&A panel other questions, so I think we're done for this webinar. Again, thank you very much for your time and for your attendance at this fourth Flex Industries webinar, and we will catch at the next one. Okay.
Thank you very much to all, also from my side.
Thank you very much.
Bye-bye.
Thank you.
Bye. Bye-bye.
Bye-bye.